So yesterday we did factoring, and I taught you this new factoring that I call divide and conquer. Would you please try to do this with divide and conquer? It's also called factor by groups. Group the first two together, you factor it. Group the second two, you factor it. And it's all about factoring. Did you realize x squared came out? And then it's x minus 5. And then did you realize 6 came out? I think it's smart to say plus 6. You can't just have a 6 hovering there. It's got to be attached with something. So we say plus 6 parentheses x, oh wait, it is the same. Yay. They are the same. If you ever find that they aren't the same, then something's going wrong. Those things in the parentheses need to both be the same. They can't even be like one's x plus 5 and one's x minus 5. They have to be exactly the same. Because then they are the common factor. And they go out to the front. And if you're wondering, like, how do you tell what's left? When you're dividing, you're typically just doing this. You're really saying, I'm going to divide out the x minus 5 like that. And this crosses off, and this crosses off, and what I'm left with is x squared plus 6. Now, if I want this thing to say y equals, because like most equations start like that, but if I want the x-intercepts, I would set y equal to 0. And if I want the whole thing to be 0, this is really easy. 5 is one of my zeros. That's one of my x-intercepts. But think for a second, you'd have to make that be negative 6. How could you take something and square it and have it come out to a negative? Not with real numbers, you can't. So this has solutions. It has 2 solutions because it's x squared. That tells you there's 2 answers to it. But they aren't real. It would involve imaginaries. So this one was easy to figure out because it's what makes it equal 0. This one's hard to figure out. So you write it out and you go x squared plus 6 needs to equal 0. And you can solve this. You will use I. Subtract 6, x squared equals negative 6, square root. This should feel mildly wrong, and you're like, wait a minute. Oh yeah, you can do this if you use I root 6. And did you remember absolute values? At least a third of the class got this wrong on the test because you forgot that it has 2 answers because of the absolute value. It's going to give you plus and a minus answer. X is positive I root 6, and x is negative I root 6. Yes, you can write plus and minus I root 6. Now, I want to mention, it's really important to understand these are solutions. They're just not real solutions. So how many solutions are there? 1, 2, 3. There's 3 solutions. How many of the solutions are real, though? Just 1. So then, when you go over to this line here, real roots, oh, that was the 5. And if you want it to be x equals 5, I would accept that. If they had asked for x-intercepts, you would have to say 5, 0 form if they wanted a point. They didn't ask for a point, so I don't have to write it this way. You could have written it that way. All right, in imaginary roots, plus and minus I root 6. And I really need an x equals in there. Now, I could also call those zeros or roots, just so you know. The word root and the word 0 are interchangeable. Okay. That was called factor by grouping. The reason you need this long division thing that I've been working you up to is because when they start with x to the 5th and they have a whole bunch of terms, You can't do factor by grouping anymore. So I'm just showing you, don't copy this down, please. You'd just be wasting your effort. That could be factored if you knew how to do it. And that's what I'm teaching you today, is how to factor something that's that gross, that complicated. And there is questions on your test like that. So how do you factor it? You use a process that involves long division. You would take this whole thing and you would divide it by something like, don't write this down, I'm just trying to give you the big picture. That's what we're doing today, is stuff like this. We won't have any that are this complicated, but it'll allow us to do long division where there's the big house thing, you know, like normally you've got a division problem where this is like 20 and this is like 7. You got stuff in the house and stuff outside the house. All right. You do not have to memorize this, but it's the right math word for it. That is called the dividend. And that is in the den. I think of it like a bear crawling into a den. Here's the den. Right here, I'll make it red. See, it's got open on one end so the bear can crawl in there. The dividend is in the den. And this part is called the divisor. I like to think of it as the divider because you're dividing by that. 20 is dividing by 7. All right. So again, if I was going to do 7 and 20, I just want to remind you the process. I go 7 times 2 is the closest I can get. 7 times 3 would be too big. And then I do actually multiply it. 7 times 2 is 14. I draw a line, make this the opposite. And now I have 6 left. And then I ask myself, does 7 go into 6? No. And so then that's the remainder. So then what do? If you have a remainder, you go, well, 7 times 2 is the closest I could get to factoring it, but to make it work, I have to add the remainder. Okay, now let me show you one where it is long division of polynomials. You need to write this one down. X squared minus 2x minus 3 divided by x minus 3. This one's the dividend, it's in the den. This one's the divisor. Okay, so how do you do it? Remember how we always would put a number up here when we were doing it with, regular numbers? Always start with an x. Everybody put an x right there. And then what did we always do next? We took that number and we multiplied it like this. But this has got 2 parts. So that's what we're going to do, is we're going to multiply the x times the x and get x squared. See how this is working? And the x times the negative 3 makes negative 3x. After we multiplied, do you remember we'd always put a line like this? And then this is the part where I kept on saying, you're not subtracting. You now make it the opposite of what it was. So this one becomes minus, and this one that was minus becomes plus. I made them the opposite of what they were. Now, zooming in on this part, x squared and minus x squared cancel each other out. Could I put a 0? Yeah, but it's just going to make it look more clunky, so I don't need the 0 there. And then I combine. Notice how it's not really a subtract problem because the minus is on the top. Negative 2x plus 3x. If I combine them together, I get 1x or just x? Okay, cool. Then do you remember in long division what you do with an extra number like this? Bring it down. All right, so far it was all a lot like what we did before. We'd put a number on top, we'd multiply it out, we'd put this line in here, we made these the opposite. It was a little weirder than last time, but we had an extra number here, we brought it down. Now we start the process again, just like before. You go, does x minus 3 go into x minus 3? Yeah, how many times? 1. And do you think that's positive 1? It is. If you're just saying 1, it goes in there one time, then it's positive 1. Now, I'm multiplying it out again. This one gets times by the x is x. Wait. This one times the x makes 1x, or just x. 1 times the negative 3 makes negative 3. Those matched up perfect. Now, technically, right here, I haven't switched the signs yet. So they don't cancel until I switch this to minus and that to plus. See why I have to switch those? And then they're all gone, which makes a 0 remainder, which means it worked. There's no remainder even. So this part that's underneath the root is x minus 3, which was over here, times what? X plus 1. And do you get we factored it? Now, I know you could have factored that faster in your head. But by learning this process, you can factor gigantic, nasty polynomials by using this process. All right. So you don't start a kid on doing gigantic, nasty polynomials. All right. So let's just start on a nice, easy one. Without my help, see if you could do x squared plus 5x minus 6 inside the den. So that's the dividend. And then out here, we're doing x minus 1. Can you long divide these two? Because if you can, then what you'll end with, if there's no remainder, is a factored polynomial. It's important to know how to start. Seiji, how do I start? Very good. Now, by the way, on a more complicated problem, if you try the x and it doesn't work, then it'll be an x squared, or an x to the third, or an x to the fourth. But to start with, for now, on the easy ones, just start with an x. And if that doesn't work, go up to x squared. All right, how do I know if it worked? Well, this is the part where you multiply. See if you can finish this thing off. I'm going to pause for a second while you give this a shot. Okay, so here's what I was hoping to see. X times x, x squared. X times the negative 1 here, that makes negative 1x. I draw a line. I do opposite, opposite. Did you remember to change that negative 1x to a plus x? So then you got 6x. And then I drop it down. And then I ask myself, does x minus 1 go into 6x minus 6? Yes, it does. And if you're like, I don't get what's going on there, just put a number here. Like, try putting a 1 here. And then you go multiply it out. That's 1x minus 1. Ooh, I got to put a 6 here. Raise your hand if you figured that out. Sweet. 6 times x, 6x. 6 times the negative 1 is minus 6. 6x minus 6. Draw the line. It's really easy to forget this. Opposite, opposite. And then they all cancel, and then you get 0 remainder, which means it worked. So that means my answer, and this is important. Did you actually write your answer? You got to write this times this makes equals that. X minus 1, x plus 6. You can reverse those two if you want. But there you go. Raise your hand if you had it right. Awesome. So you can now divide long division of polynomials. Now those were kind of easy ones. And of course they get a little harder. So let's go back into the notes here. Go to page 2 of the notes. Review long division. We did that. It's vocabulary, like the dividend is in the den and the divisor. Apply long division to polynomials. Well, we just did that. Sweet. Okay. So if you had to factor that, you would not be able to factor by grouping. Because if you tried to divide it up into two parts, this part's a triple and this part's a double, and you might think that that would work, but it doesn't. So you can't do divide and conquer for that kind, so you got to do long division. On to the next page. This is just remembering how to do it with regular whole numbers. Does 7 go into 83, and it would look like this. We've already done enough of those, so we don't need to do that. Next page. Dividend, divisor, and that's called the quotient. Quotient is like the answer to a divide problem. On to this one. Here's your first one where I'm not even setting it up. Can you set it up, do long division, get your answer? Make sure you actually answer the question. They said, is that a factor of that? I'll pause. So to make sure you started right, did you put the x minus 1 on the outside? Okay, good. Did you remember to start with an x? Okay. How many of you are done already? Sweet. X times x, x squared. X times negative 1, negative x. Draw a line. Don't forget opposite, opposite. Very common to forget that. Then this becomes 3x. These canceled. Bring down the minus 3. Now, how many times does x minus 1 go into that? It goes in 3 times, and that's a positive 3. If you're not sure, just default to a positive and see if it works. Sometimes it needs a negative, but you'll see by doing this. 3 times the x, 3x. 3 times the negative 1. I better write in darker color. 3 times the negative 1 makes negative 3. Draw the line, opposite, opposite, and then they're all opposites, and so you get 0. But did you answer the question? Is that a factor of that? Yes, it is. And the factors are x minus 1 times x plus 3. These two right here. And that's equal to what's underneath here. They're called the dividend. All right, moving on. This is your first one that's got 4 parts. I'll pause and give that a try. All right, this one gets a little more challenging. If you started with an x, I hope you realized that the x didn't work. Because when you got x times x, that was x squared, and it wasn't matching up with that x to the third. Do you get if you'd used an x squared? Then it would have matched up with the x to the third, but not quite. Because x squared times, that makes x to the third, but I wanted 3x to the third. 3x squared. Raise your hand if you started with that. Nice. Tons of you did. That's awesome. Then I ended up with 3x squared times the 2. 6x squared. And I draw the line. Opposite. Opposite. So it's really 13 minus 6, which is going to be 7x squared. Bring it down. Then I realize I need to match this term. You're going to start realizing that's the key thing, is the front one. I got to get that 7x squared to match. So I'm going to put a 7x here. Because then 7x times x will make 7x squared. 7x times the 2, 14x. Draw the line. Don't forget the opposite thing. Negative 4x, drop it like it's hot, minus 1. And now a minus 4 goes here, and something's going to happen. Negative 4x. Negative 8. Ew. Do you get we have a remainder at the end? But it'd be really easy to mess up the remainder now, because You draw the line. Did you remember to do opposite, opposite? And that 8 and that minus 1 makes 7, and 7 is your remainder. So what I'd be looking for on the test is this a factor of that? No. Remainder was 7. Okay. I think you got it. I really do. Try this one. The pink page. And I don't have to have you leave here as absolute experts on this. Of course, we'll review it when you come back from Thanksgiving break here. Opposite, opposite, and whoa, both things canceled out. Do you get, when I do opposite, opposite, I have nothing left for either one of these? If you just bring down a 2x, do you get, you're going to have a problem because you have like 2 things over here and only 1 thing there, so you got to bring down both things. Did you, how many of you guys kind of realize that? Good. Your intuition is good then. And then you go, what do I put here? Default to a positive if you're not sure. 2 times x is 2x. 2 times the negative 5 is negative 10. Draw the line. Opposite, opposite. They cancel. 0 remainder. Sweet. There we go. Is that a factor? Yeah. And now my answer is it written out. X minus 5 times x squared plus 2. Did you remember that part? It would be so sad to mark it wrong because you didn't actually show your final answer like this. And yes, on the test, you would get it wrong if you didn't show it in factored form. All you have to do is write it like that. And now it's in factored form. Okay. Now, I will warn you, there's one kind that gets weird, and it's not this green one. It's this yellow page. This one gets weird. Let's do it together, and then when it gets weird, I'll show you what to do. If you can concentrate for one more math problem, you're going to have 5 days off. Okay, what did I say it always start with? X. Is that actually enough? No, it's got to be x what? Squared, good. And that's not the weird part. Opposite, opposite. So far it's been pretty normal. It's about to not be. When I bring down this plus 15, it's still okay. The weirdness is going to happen next. Did you realize that we'd have to use a negative 2x up here? Did you get that? Negative 2x times 2x. Wait, plus. Wait a minute, I want to match it exactly. Yeah, yep, I've got it right. Negative 4x squared, because later I'll change the sign, right? Okay, and then negative 2x times the negative 5 makes 10x. Ooh, that's weird. But that's what you do. We're good so far. Did you remember to do opposite, opposite? And now is the part where you have to be smart about this and go, oh, I guess I have a negative 10x and a plus 15, but I can't like subtract them from each other because they're not like terms. So you just write it like that. Can you just keep going? Yes, you can. So I guess I need a 5 at the end. Ooh, I want to match it exactly. A minus 5 times the 2x makes minus 10x. Notice I want to match it exactly. Negative 5 times positive, or no, negative times negative makes positive 25. And you don't get to just quit once you realize there's going to be a remainder. The whole point then is to show me the remainder. Opposite, opposite. Negative 25 and positive 15 makes negative 10. So is this a factor? Nope. The remainder is negative 10. Okay. That was one where there was a missing term. Now, some teachers teach that you have to go and say there's x to the third, there's x to the second, that you have to go write in a plus 0x to the first. I don't teach it that you have to do that. You could, to hold the place, you could put a 0 there, but that's not something that's required. As long as you can handle it when something weird like this happens, and you just have to go negative 10x plus 15. All right, and that's it. So you have a worksheet. Now, I know I can't assign homework over break, so I'm not. So you have a fair amount of time left in class. Can we verify that you have like 18 minutes in class? I think we do. I'm gonna verify what time you get out today. Today is Tuesday. Is there any anchor time today? No anchor time, so then it's just like a Monday. So then basically you guys are out of here at 11 a.m., I believe. You guys agree? Okay, so then you have 16 minutes left. I'm going to ask you to literally do two problems, but then it's not homework. It's in-class work. You do those 2 problems in class, and then you're done. Now, I might go assign more of these later, but I'm not even going to promise that. All I know for sure is you should do the first 2 questions, and yeah, there's like a part A and a part B, but do 2 problems of the worksheet. Yes, I'll put a Dropbox up to submit. And that's all we have for you for today. Do the first 2 problems of the homework. But it's technically not homework. It's in-class work because it has to be done by the end of the hour, but there's only 2 problems. So that's it.